You have customers, you have satisfied customers. But what are we talking? We are talking loyal customers. So who is a loyal customer? Somebody who will give a testimonial, somebody who will write about you in social media, somebody who will bring new customers. You need to define them. You need to measure how many such people are there, and you should find a way to increase the percentage of loyal customer. So over 3 years, if I increase the percentage of loyal customers to 1% to 10%, that itself will make a big difference. So these kind of projection is required. And there is also a tool called Hoshin planning. And maybe in ISO audit and other things, some people might use. And the same tool we are also going to discuss, and then we are going to equip you in the master black belt level. And this Hoshin planning will clearly show the connection between the strategic goal and the daily activity. And what the daily activities are nothing but the learnings from failures. So all the unless and until you have the habit of fixing the failures, you do not know the list of daily activities to be performed, what needs to be controlled on a daily basis. So this is required. And Six Sigma experts also need to be good change agents. So you have to go up to the MBB level to really become a change agent. All right. So with that note, I think we have
one more.
Yes, sir.
This gives me a lot of solutions to my actually what I was looking forward to. One more thing. I am in touch with a couple of universities here.
Okay.
So I just want to pitch, because I am trying to actually initiate them, their postgraduates or management students, engineering students, design students primarily. So I have talked to a couple of them in last 2 days, and I have proposed that their students can go for a yellow belt or a white belt class.
Yes.
So can we have, if you have some time or inclination, collaboration with between MSME Chennai and a university, couple of universities I'm in touch with. So if you allow, I can propose to them that we can work out an arrangement where there will be a course conducted online jointly with a university and MSME Chennai TDC. Yes. And then we can issue them certificates on, let's say, white belts and yellow belts.
Definitely, we can do that. Definitely, we can do that. Which place you are trying to do it?
In Jaipur and in Chandigarh.
Jaipur and Chandigarh, yeah. Very good.
So I am in touch with a couple of universities. I go and teach them in two universities in Jaipur, and in that connection, I've in touch with the university.
Your first question and second question has got a connection.
Right, that exactly. So because that is why that is the challenge I feel. Yeah. So when I talk to the entrepreneurs, and I can tell them that okay, maybe down the line 3 years, you will need people who are initiated in the concepts.
All the universities, offering the Six Sigma skills to the students is an essential thing.
So the crux is here. Will you be willing to enter into that kind of a collaborative effort?
We are already doing it for past 3 years. We have a collaboration with near about 55 higher education institutions in Tamil Nadu.
Okay.
They include Government College of Technology in Coimbatore and Government College in Bargur, and then Coimbatore Institute of Technology, PSG Tech, and then Wales University here in Chennai, and then Sairam Group of Institution and Loyola Engineering College in Chennai. Near about 50 plus institutions, we already have MOU. We have already trained thousands of students, but problem is, there are lakhs of students who require the skill. And in Chandigarh and Punjab, right? So I don't know whether such awareness is there or not, but what you are going to do is really a good job, much needed initiative for education institution. We will do it. We will be happy to collaborate.
Right, because in Jaipur I am in touch with the top universities. They are ranked number 1, number 2, number 3 in top 5, and also the university in Chandigarh is about the same level.
For students, I used to tell them Six Sigma is nothing but project execution methodology. When you are given an opportunity to do a project in a company, how will you do it? This is all about the Six Sigma methodology. We'll train them, and of course we make it customize it to suit the students. Good, sir. We'll discuss even separately on this, and then we will definitely take it forward. Yeah, and good to have a few more people. I think all of you, good everyone is here. All right. So this particular session, we are going to understand little statistics and very, very important learning. What is exactly Six Sigma? How is this 3.4 DPMO comes out from Six Sigma? Right? The meaning of Sigma. Sigma means standard deviation. What does it mean? We all studied in the schooling, 7th standard. We know how to calculate standard deviation, but today again we are going to calculate. We are going to understand, and we'll also understand the meaning of a Six Sigma process and also normal distribution. And this is going to be the great foundation for all of you to build your further knowledge in the field of Six Sigma. This is mainly because this knowledge is missing. People are not able to connect, and that will definitely happen here. So certain slides I will cover live, and certain information I will play through video. However, I wanted to keep it very lively. I want participants here to participate like Mr. Vivek, right? Prefer to be on video. One of the principle of lean is self-monitoring. If you are not monitoring yourself, and that could become a reason for your failure. So see to that you monitor yourself, and thereby you are preventing the failures. And let's see. So I'm just sharing few my slides. Please confirm my screen is visible and I am properly audible. Great. So part 2, because I did a session yesterday, part 1, and all my GBBB classmates, you will definitely have that idea of the part 1. Okay, these are all regular rules. So any company, any product, any service, right? There will be price pressure. You all know. Customer always expect you to reduce the price. While expecting highest level of quality and faster delivery, they will also expect you to reduce the price. So how are you going to meet such challenges? So it is very important to understand what actually constitutes the price of the product. There are three main things. One is the basic cost, A. The other one is the existing failures. We call it cost of poor quality. C here, actually, C. And then what is B? Company needs a profit. Company needs a profit. So profit, base cost, cost of poor quality. All the three constitutes the price of the product. The first one is base cost. This is cost of poor quality. And the third one is profit. And now tell me, your customer is willing to continue the business with you only when you reduce the price. Otherwise, they want to move to someone else. And now how will you manage the situation? Or what will be your priority? Will you focus on reducing the base cost? Or will you focus on compromising the profit? Or will you focus on reducing the cost of poor quality? What could be your priority? And all of you can try to answer this question. What's your choice?
Reducing cost of pure quality.
Very good, right? If you say profit, and nobody will like your idea. If you say I will reduce the base cost, like I will reduce the resources, reduce the manpower, reduce the raw materials, of course you need to be efficient there also. But beforehand, you have a lot of failures. Arrest those failure costs, right? So working with what you call the base cost straight away is not a great idea. And compromising the profit is also not a great idea. And the first focus should be on reducing the cost of poor quality. And that is why, we must educate people on what is cost of poor quality. Cost of poor quality can be direct. Cost of poor quality can be indirect, right? There are several ways, we can convince people on, the importance of reducing cost of poor quality. This in detail we discussed yesterday. This curve, which is continuously going up, this is cost of good quality. You spend more on good quality and your quality level will continuously go up. That's what this curve is saying. At the same time, if you don't spend more, on cost of good quality, if you don't improve the quality level, if you prefer to stay at lower quality level, there'll be more failures. There'll be more failures. As you keep on improving the quality, the failures will keep on coming down, isn't it? And that's why this curve is going down. So this curve has an upward trend, what we call it as cost of good quality, and this curve is downward trend, what we call it as cost of poor quality. You know why it is going upward and why it is going downward, right? When I combine the two, this is called a total quality cost, and this total quality cost curve takes a turn here. This is what we call it acceptable quality level. You need to understand whether you have at least come to this level or not, right? And the point what this acceptable quality level is telling us, this is the point at which our profit is getting maximized, right? And if you wanted to know, then probably we require the revenue curve, and then we find out the difference between the revenue and the cost of quality, which is cost of conformance plus cost of non-conformance, and that's how it is. And when it comes to cost of good quality, there are two activities we basically do. One is prevention, another one is appraisal. Prevention is, like this, even this training program is prevention, creating SOPs, designing a product, and then, developing production schedules, and all those things are cost of prevention. And appraisals are like inspection, calibration, audits, all of them are appraisal, right? And this is what I meant, your revenue curve, and the difference between the revenue curve and the quality curve. At one point, the gap will be higher. So that point we call it as acceptable quality level or desired quality level. Generally, we must at least bring the quality to this level, because that's where our profit is maximized. If you don't come up to that level, then that's where people are compromising. So we need to educate them to come up to this level, and then even we sometimes we may have to go beyond if the market situation demands. But the problem here is when you go beyond this level, what happens? It will be at the expense of your profit. In spite of you doing very well, still your profit will be lower. So generally companies don't go beyond this, but it's very important to come up to this level. And then when it comes to the cost of poor quality, and generally companies think, the poor quality is smaller. And that's why, another reason people don't immediately accept for these kind of, Lean and Six Sigma initiative. You have to tell them the failures are not just what they see. There are many things that they don't see because, they don't have the real, the knowledge to understand. So we need to educate them to understand that there are other forms of failure exist. So like the iceberg, only the tip of the iceberg is visible, and people generally think that, whatever they see, that is the only portion. But the reality is there is a bigger portion that lies inside the water. And what we see above the water is only, the visible failures, only the measurable failures. But there are a lot of invisible failures, and there are a lot of immeasurable failures. If you wanted to see that, we need to uncover the water. Similarly, we need to, make people understand, certain quality principles and certain approaches, so that they will also realize there are many, many other forms of failure that exist in the same organization, which they know so far they might not know. And for example, if you are doing a work in a particular way, but if a better way of doing a work exists, and if you really don't adopt the new method, that is also a kind of wasteful activity we are doing. That will also then account for a cost of poor quality. So there are many things I have written here, like the overproduction and over processing, going beyond the spec, and making your customer get dissatisfied with your products and services. And doing all these things are also failure. But knowingly, unknowingly, all these things might be happening in your company. But they think that it just happened once. But actually, we need to really take all these things, give importance, and then fix them, and thereby, they understand that these forms of failure, we call the cost of poor quality, can even account to 20 to 45% of the sales. If 20 to 45% of the sales, can be burnt in the form of cost of poor quality, my only question is, why don't you fix them? Why don't you reduce them? If you reduce cost of poor quality, what will happen? Can somebody guess here? If I reduce the cost of poor quality, if I reduce the failures, will it improve the revenue or will it improve the profit? What is your
Profit. Profit it will increase directly.
profit?
Will increase the profit.
That is the
Increase
beauty
the profit.
of fantastic. That is the beauty of fixing the failures. Even after knowing that fixing the failures will improve the profit, if the management doesn't change their mindset, you just leave them. They are happy to live with failures, and they are happy to compromise on their profit. The only way you can maximize your profit is fixing the failures, fixing the problems, reducing the defects, right? And tell them, and such projects are called Lean Six Sigma project. Such projects are called Lean Six Sigma project. You can fix defects, you can fix waste. So you must also educate them on the difference between defects, and yesterday we discussed defects and waste. If product has a non-conformance, it's called a defect. But the way you produce a product, if that is not efficient, then what you are doing is waste. For example, this webinar is planned for 2 hours. Let's say for some reason I am not able to complete it 2 hours, I stretch it for 3 hours. This is an illustration of an inefficient way of handling the class. Am I correct? What has been scheduled for 2 hours should be completed in 2 hours. Otherwise, what happened? That can lead to customer dissatisfaction. You may have to skip your dinner, or you have to go the class halfway, and all these things lead to customer dissatisfaction. So probably next time people may not trust you. Oh, this fellow will call and then keep on stretching it up to 10 o'clock or 11 o'clock. So we need to understand that reducing the defects and reducing the waste will directly maximize your profit. And that's why Six Sigma or Lean Six Sigma is considered as profit maximization approach. And tell me which owner, which company doesn't like maximizing the profit, right? Everybody needs profit, and everybody like to maximize the profit, doubling the profit, tripling the profit. Yes, all these things are possible, right? So I have a small question here to you people. Excessive movement of machine part. A machine part, a machine is designed in such a way that a particular part is moving excessively. Let's say the arm of the shaper. The shaper arm is set in such a way that for doing a machining of 50 mm, it has to move for 300 mm onward, 300 mm return. In a day, 1,000 times the arm will be moving. And now tell me, what is this excess movement called? What kind of waste it is? Because there are
motion.
It's wear and tear.
Wear and tear, yes.
Waste of excess motion, number 2.
Waste of excess motion. Actually, there are 7 types of waste exist. We need to, I need to educate all of you on 7 waste. Transportation, unnecessary transportation, excess inventory, and excess motion, right? And waiting. For example, all of you join the meeting at 7 o'clock, but I start the class only at 7:30. The 30 minutes, all of you will be waiting. So waiting is a waste because nothing happens productively, isn't it? So waiting, overproduction, overprocessing, and finally defects. These are the 7 basic types of waste that will exist in any business process, right? And this was coined by the Japanese quality guru Taiichi Ohno. Yesterday I have shown his photo, Taiichi Ohno, right? And according to his definition, excessive movement of machine part is called motion waste, right? And so this must be reduced. How many companies think in this manner, right? So what happened? The excessive movement, there are several failures. One thing is, it will take more time for the machine to complete the process. Agreed? And number 2, because of the excessive motion, and as Mahalakshmi said, there will be additional wear and tear. And number 3, it can cause accidents, right? And number 4, the electricity consumption, isn't it? So many ways, the company's money and profit is getting burnt. And just one form of waste we discussed, and that is giving 4 different ways of burning your profit. So likewise, 7 types of waste exist. Change over time is an example of cost of good quality or cost of poor quality. Can somebody tell me what is change over time? For example, yes, Swapnil, you are going ahead. Yeah.
Yes, sir. It is the time taken to change the setup for during
Very
machining.
beautiful. Change the setup. The time you require to change anything. For example, imagine a restaurant or a hotel. They are offering breakfast and lunch and everything. So up to 11 o'clock, they offer breakfast. Anytime you go before 11 o'clock, you get all breakfast. Idli, dosa, chapati, pongal, whatever you want, they are giving. But after 11 o'clock, they will not be able to offer you breakfast. And they will not offer you lunch also. Because the lunch, they can start only by 12 o'clock. What does it mean? There is a changeover time of 1 hour. During that 1 hour, nothing happens. You don't get breakfast also, you don't get lunch also. The hotel is, just idle, isn't it? Suppose if this changeover time is 4 hours for some reason. After 11 o'clock, when they will start the lunch? 3 o'clock. Do you think customer will come to your hotel? So you are losing all your business by keeping your changeover time higher. So you should react whenever the changeover time is longer. And the changeover time not necessarily be 4 hours for you to react. Isn't it? Whenever the changeover time is more than 10 minutes, you must react. You must consider that as a failure. I do not know how many of you so far considered having a changeover time in 2 digits is a failure. Is anybody treated, changeover time in 2 digits as a failure so far in your career? No. That means, all these problems, must be visualized, right? So changeover time, setup time in any process is actually, an example of cost of poor quality only. You must reduce it because we are not doing any productive work, right? All right, this and all, but certain slides I wanted to skip because you all know this, right? Process-centric approach. Same process will produce only same result. Same orange tree can give only orange fruits. But what your management wants? Your management wants apple because they are very clever. Apple can be sold, in a better price. And you can't produce apple from the same tree. Same way, same process cannot give them better result. So process improvement is unavoidable if the organization is looking for an improved result, isn't it? And mathematically, we call it y equal to f of x, right? Because our results depends on several other factors, isn't it? Our result depends on several other factors. So y is the dependent variable and x are the independent variable, right? And if you want to facelift a product, facelift a process, Six Sigma gives a methodology called DMAC. For example, the oranges what you are selling in the market are not up to the mark. Then you must find a way to improve the oranges. Put some quality water and then fertilizer. Take care of the tree, little more better, so that your oranges can really become better, right? And this is called facelifting a product, facelifting a process, and you can use the methodology called DMAC. But if you want to change from orange to apple, why do you want to change from orange to apple? All your oranges are already better. You are already better than your competitor. Then, you can think of a new product development. In addition to selling the oranges, you can now sell apples also in the market. So now how will I produce apple? I am already known for, my quality of fruits. Now it is very important for me to sell any new item with the best level of quality. So in order to produce apple directly with the best level of quality, and Six Sigma gives another methodology called DMAT-V, right? You are developing new product, right at the time of launching the product, the quality level is Six Sigma, best in class quality. And this is called DMAT-V, and we call this approach as DFSS, designed for Six Sigma, right? So you can easily understand this mathematical equation y equal to f of x. If y is considered as the taste of the coffee, and tell me what are the x variables here? If y is considered the taste of the coffee, what are the x variable?
Quality of milk.
Quality of milk, yes. Yes.
The quantity of milk used,
Very good. Quality of milk, quantity of milk. Then
Water
then the
used
sugar content,
and the process.
very good. Water used,
process.
the process, the methodology, the sugar, temperature. Now, the taste of the coffee is the Y variable. And all these things are X variable. Let us say I am running, 100 plus restaurant across, a state. Throughout the state, I am running 100 plus coffee shop. And there were a lot of complaints, I am getting from all the restaurant about the strongness of the coffee. Whenever a strong coffee is ordered, customers are highly dissatisfied. Now tell me, what could be critical factor now? You have so many factors here, which are named as X1, X2, X3, isn't it? X1 is milk, X2 is coffee powder, X3 is sugar, X4 is temperature. And which factor is critical to strongness of the coffee? Come on.
So the process
X2.
Coffee powder.
Yeah, coffee powder is critical to
X2.
strongness of the coffee. Isn't it? You put more coffee powder, coffee will become more stronger. Suppose if you put less than what is required, coffee will become lighter. Your process is not able to handle the right amount of coffee powder. Isn't it? Now coffee powder becomes critical factor. This is now coffee powder, the quantity of coffee powder is the root cause with respect to the strongness of the coffee. Similarly, if you are manufacturing a product, let's say you are manufacturing a concrete block, the compressive strength of the material is not up to the mark. Now, which is the critical factor? Like here you said directly straight away, sir, coffee powder is responsible for strongness of the coffee. Now tell me, which is responsible for compressive strength of the material? You are producing steel rod, tensile strength is not up to the mark. Now, which is responsible? Here, the root cause is already known. How do you know the root cause? You have already done several experimentation, am I right? You have already done several times, you prepared coffee. Every time you put more coffee powder, your coffee is becoming stronger. Every time you put less coffee powder, your coffee is becoming lighter. Some experimentation you have done, and with that experimentation, you gained a knowledge and which is saying you that coffee powder is the critical to strongness. Same way, can you do some experimentation to confirm that a particular factor is a root cause or not? This procedure of doing small experimentation is called hypothesis testing, which you will be mastering inside the Green Belt training program. And now I made it simpler. And also between the coffee powder and the strongness of the coffee, what kind of relationship exists? Are they positively related or negatively related? Positively means when I increase the coffee powder, strongness will increase. When I decrease the coffee powder, strongness will decrease. Increasing the X, if it causes increase in Y, it is called a positive relationship. If the increase in X causes decrease in Y, that is called a negative relationship. And tell me what kind of relationship exists between coffee powder and your strongness, X and Y. Can somebody comment? Is it positive relationship or negative?
Positive relationship.
So if you know the relationship, you will be able to offer solution to the problem. For example, what is my requirement? I want to increase the compressive strength of the material. I want to increase the strongness of the coffee. Now, what is the solution? Increase the amount of coffee powder. What is your available formula? SOP, adding 6 grams of coffee powder for 100 ml of milk. Now, I am going to change the formula. 8 grams of coffee powder per 100 ml of milk. This is called optimization. This is called optimization. So a solution to a problem is nothing but optimization of your critical factor. How many of you understand? See, studying the criticality, how did you understand? Through some experimentation. Am I correct? Increasing the coffee powder will increase the strongness. That is an experimentation that helped you to understand the criticality. We call it hypothesis testing. Now I have another purpose. I should do some more experiment to understand at what level I get the desired level of strongness. And that level is found to be 8 grams of coffee powder. This is called, design of experiments. How many of you understand the difference between hypothesis testing and DOE? All of you are able to understand? All of you are with me on this? There are two things I am telling you. One is hypothesis testing. Another thing is DOE. What is the difference you have understood from me? Come on, guys.
Hypothesis, we cannot know the exact issue there.
Yes.
Yeah, while doing the experiment, we can come out of the results. I mean, like, because of this, we have got this issue. So we can get the output.
Very good. So hypothesis testing will tell you whether the factor is critical to the result or not. Right? Whether the factor is critical to the result or not. But design of experiments, you can take you one step ahead. Over and above telling you the criticality, it will also tell you what will be the optimum value of X at which your Y will also get optimized. Clear? When I keep the X at 8 gram, I get the strongness of the coffee at the desired level. So give the, that means DOE can take you to the solution to the problem. But hypothesis testing will drive you towards solution. Do you understand now? Hypothesis testing is driving you towards solution, but design of experiments actually takes you to the exact solution, right? All right. So solution is nothing but factor optimization. But which factor you will optimize? Only the critical factor. Am I correct? But how do you know the factor is critical? By hypothesis testing. And then once you know the criticality, you optimize the factor, which is called DOE, right? So now I need a sweet coffee. Earlier I wanted a strong coffee and you said, coffee powder is critical. Now tell me which is critical to get a sweet coffee. Come on. Easy questions, right? Which is
X3 sugar need to add.
Sugar. And what is the relationship between sugar and sweetness? Positive relationship or negative relationship?
Positive.
Once you know that a factor is critical, once you know the relationship between the critical factor and the Y variable or the problem, tell me, will you be able to solve the problem and offer a solution? In order to make a coffee sweeter, what are you supposed to do? You need to increase the amount of sugar. You don't have to be a chef, to offer this kind of solution. By doing some simple experimentation can make you decide better than a chef, isn't it? That's why Six Sigma experts can work with any subject matter expert, SME. You may be a medical doctor or you may be, a cardiac specialist, but I can still work with you as a Six Sigma expert. Are you deciding correctly or not? I can tell you. That's why Six Sigma experts are highly paid. And that too, if you get trained from some good platform, you will see that you are compensated adequately, and then you will grow very fast, and eventually you will get some very good leadership roles. All right. So what is next? Yeah, this I will quickly go through because already I discussed define, measure, analyze, improve, and control. And a problem is considered to be defined if we make it measurable. And the goal now during measure is measure without error. Measure without error, right? And then find out the baseline. Then go to the analyze to identify the factor which is critical to the gap in performance. What will you do then? How do you identify critical factor? Hypothesis testing. And so far, your company could have taught you brainstorming. Your company could have taught you fishbone analysis and all those things. But we are going to start you little more above all those things, because these are easy method. Any analyst and any professional will do. Anybody when there is a problem, they draw a fishbone diagram. Of course, that is required, but we need to be little more smarter. We'll do hypothesis testing. Then we move on to improve, and improve phase is the phase where we start thinking and discussing about the solution. What is solution? Optimizing the critical factor. What is optimizing a critical factor? Assigning a particular value to your factor. When a doctor treats a patient, if the patient is a child, paracetamol 250 milligram will be offered. That is the solution to the problem there. If the patient is an adult, same paracetamol, maybe doctor might prescribe 750 milligram. Isn't it? Depending on the problem, the factor is, assigned a value. Similarly, you should also set an optimum value to the X factor at which your Y will get optimized. All right. And factors, critical factors, maybe one, maybe many. If there are many factors involved, problem becomes complex, becomes the job of a black belt, isn't it? And sometimes multiple departments are involved. Problem nature is cross-functional. You have to talk to many people to understand the problem. Everybody will confuse you, in a different direction. And these are all leading to a situation, demanding a black belt expertise, right? And that's how it is. And then control. Once the problem is solved, why our problem happened? Some of the X variable deteriorated. Coffee powder was not, put at 8 gram. Instead, it was put at 6 gram only. The same mistake should not come again. Can you, how will you prevent this problem in further? First of all, you update your SOP. You will update your SOP, and then in order to make sure every chef gets only 8 gram of coffee powder, will you also think of offering a specific scoop which can always get you only 8 grams? Am I correct? These are all called control measures. Your daily routine is changing. Earlier, you have been using, everything that you have in your kitchen. But now you are prescribed only to use a particular kind of, this scoop or the spoon, which can get you only 8 grams. And your tumbler is fixed. Everything is fixed. And this is what is called, control phase. By following the control plan, your process will never deteriorate again. At least for the same reason, it will not deteriorate. Maybe for a new reason, which we will take it up as a new project. But if you have the habit of, solving the same problem again and again, it simply means you don't know how to solve a problem, right? You can solve a problem, but solve it only once. And this is the power of Six Sigma methodology. And always we train our participant, we handhold to the extent possible. Step by step, we take them. Because small steps, easy to take. When you make the step complex, then not everybody, cannot jump. So we broke down the complete DMAC process into 15 simple steps. That means, your learning is going to be a mere cakewalk with us, right? You can comfortably learn. So far, good? All of you? Why others are not answering to me? You don't like the class?
Yes, sir.
Yeah,
It's
say yes
interesting.
or no. That is important, right?
Yes, sir.
So the learning education comprises of two things, teaching and then learning. I need to know whether you are learning from the other side, right? Otherwise, it is
sir.
meaningless. Doing a teaching without learning is meaningless. You need to often educate me that you are learning, right? So we are moving on to statistics and normal distribution for Six Sigma. What is that all of you are seeing here in my slide? A ring of fire, am I right?
A ring of fire. Sir.
If I ask all of you to come one by one and jump into the ring of fire, will you do it?
No,
Right?
sir.
You don't do it, right? But
No,
suppose if I am your boss and you have to do it, and then only you will pay it for it, right? And
Yes,
now,
sir.
yeah. So imagine you are jumping, you are jumping through the ring of fire, and tell me, where will you jump?
In the
Compulsorily,
middle.
yeah, in the
In the
center.
middle. Yeah.
Can you also tell the reason why you choose the middle?
It will be safer for me because I will not catch up the fire.
Very good.
So for the
Yeah.
safety reason only I will do.
Very
But,
good. You want to jump through the center because the center point is, the safest point. Jumping inside the ring is riskier. I know. Doing business is always riskier. I know. But after choosing a risky field, jumping through the center is safer. Similarly, any business process, there will be one point where the risk will be minimum. You must run the process, you must set the process through that point. How do you know where are you running your process? Through statistical measures of central tendency. When I asked you, where will you jump? Everybody preferred center. There is a tendency towards center, isn't it? Because all of you know, center is safer. Similarly, any process, where is it tending? You can understand by calculating measures of central tendency. Why do you want to know central tendency? Then you can judge on the risk associated. You can judge on the risk associated, right? And the measures of statistical measures of central tendency are mean, median,
and
mode. What is the difference? Mean means average.
average.
Add all the value, divide by the number of values. You get the average. Then what is median?
If we arrange it in the ascending order, and then what will be the middle one?
Very good, beautiful. Arrange the number in ascending or descending, then find out the
Yeah.
center. Suppose if all of you stand according to your height, who is having the middle value, and you are called the median. And now what is mode?
What is the most repeated value?
Very good. Most
Mode
repeated
value.
value is mode. All these three can help you measure the central tendency. Depending on the type of data, sometimes you have to use mean. If your data is continuous, you must use mean or average. If your data is not continuous, you must use median. Sometimes you may have to use mode. For example, if I ask all of you to come on video, and if most of us wear white color shirts, what does it mean? People in the evening time, they prefer white color dress, isn't it?
Right.
So the central tendency of what people are thinking, how do we come to know? With the help of mode. What is mode in this case? In the example I said, many people were wearing white color dress, isn't
White
it?
color
White
shirt.
has appeared many times. So that has helped us to understand the central tendency. Hope the central tendency is clear. And now we know the center is the safest point, but when I want you to jump 100 times, will you jump all 100 times exactly at the center? Difficult. So I'll give a
It will
tolerance.
deviate.
That is why customer is also always giving you a tolerance. Requirement is 100 mm, but customer gives 100 plus or minus 0.5. Right? So there is upper specification limit, there is lower specification limit. You can see the tolerance, and now your point has become a circle. When I actually run a process, several times, what happens? There is a chances of failure. Some of your output or some of your jump may go beyond the white color circle. Am I correct? But now, you have deviated from the center, but not far off. But anyway, your risk has slightly increased. Your risk of failure has slightly increased. If you further deviate, what happened? You are going closer to the outer ring, which is actually burning. So when you move away from the center, can you understand your risk is, gradually increasing as you move towards the, the boundary? Similarly, any business process, if the outputs move towards the specification limit, the risk associated with the process will increase. How do you know how much amount of risk you are running? You need to measure this deviation from the center. If you know the deviation from the center is low, okay, it is low risk. If the deviation from the center is high, it is a situation of high risk. And this is why we require certain measures of variation. One of the measures of variation is standard deviation. You understand, right? And you can also use range. You can also use variance. Variance is square of the standard deviation, and range is maximum minus minimum. Hope it is very clear. So what is our goal now? The central tendency should be, the mean or average should be at the center. Am I right? The mean value of your jump should be at the center. Am I correct or not? For business process, the mean value of the process data should be on the customer target. Am I correct with my statement? Any average when you calculate using
Yes.
process data, that average should be on the customer target. Average on the customer target doesn't mean that every output is on the target. Am I correct? Average on the target may not mean that every output is on the target. So in order to understand how the other outputs are with respect to the center, you must calculate standard deviation. If the standard deviation is low, your process is healthier. If the standard deviation is high, your process is running a higher risk. All of you are with me so far, right? See, if the standard deviation is low, all the outputs are closer to the center. All the outputs are closer to the center, and the center is on the target. If the center is on the target, and if everything is around the center, it simply means everything is around the target. Am I correct?
Right.
This is what we need to do, right? All of you are relying on me to learn Six Sigma, and it is very important that I know Six Sigma, isn't it? So if deviation is low, it means everything is around the center. If everything is around the center, what is important now? Center should be on the target. With me? All right. So now let us understand standard deviation little more deeper, right? So this is the formula for standard deviation. Summation of x minus x bar the whole square divided by n minus 1. What is x bar? Average. What is n? The number of data. See here, I am showing a triangle here. Now tell me, if I draw a center line in the triangle, see here, center line. Is this center line dividing the triangle into exactly two parts? Come on, guys.
Yes, sir.
That means the triangle is symmetrical at the center. It's like our face. If I draw a line here, whatever you see on the right side and left side are almost same, isn't it? So the triangle is symmetrical at the center. I now remove one half of the triangle. And what I show is a bell-shaped curve. Half of the bell is visible, am I right? Half of the bell is visible. Now I remove the other half. Now remaining half is also visible. Now tell me, is that bell shape also symmetrical at the center? Yes or no?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
That means when I draw a center line, 50% of the curve is on the right side, 50% of the curve is on the left side. Am I correct? When I draw a center line at the normal distribution curve, 50% of the curve is on the right side, 50% of the curve is on the left side. And what is there at the center? Average. You see here mu. Always when you collect data from any process and calculate average, you will be surprised to see that 50% of your data falling to the right of the average. 50% of your data falling to the left of the average. This is an indication, first indication that your process data is going to follow a normal distribution. This is the motivation for us to know and learn the characteristics of the normal distribution. Isn't it? So, done. So, you calculated the average. After calculating the average, I want you to calculate standard deviation also. Yes, you calculate the standard deviation. See here, you have a formula. Use the formula to calculate standard deviation because you have a data. You have a data, right? And now, once you know average and standard deviation, I want to know how long the curve will be going. See, look at the profile of the curve, the locus of the curve. It keeps on going. It has come close to the x-axis here. Am I right? But the nature of the normal distribution curve is this will never touch the x-axis. It will keep on going. It will touch. It is assumed that the curve will touch the x-axis only at infinity. Am I correct? Mathematically, we call this type of curve as asymptote. Asymptote means without touching it will go. Similarly, on the left side also. But see here, looking at the point, the curve is almost close to the x-axis. So generally, in order to predict the entire curve, if you go up to 3 sigma limit, that is good enough. Because beyond which the area is very small. Am I correct? So if you go up to 3 sigma from the center on the right side, 3 sigma from the center on the left side, almost close to 100% of the curve is understood by us. Am I correct or not? Right?
Correct, sir.
And
Yes, sir.
that it is estimated. It is only estimated. See, statistics is only estimation. It is not perfection. Statistics differs from mathematics. Mathematics is perfection. What is statistics? Statistics is only estimation. Estimation will always have error. Am I correct? When
Yes, sir.
you want to go for construction of your house, what is that the first thing they will give? They will give an estimate. But what will be the actual cost? Always differ from the
on the
estimate,
higher
isn't
side.
it? Higher
Yes,
side.
sir.
Same way, statistics also will only give an estimate. It is estimated that 99.73% of the area under the curve will lie within 3 sigma limit. See here, center plus 3 sigma. The center plus 3 sigma, this point is called upper control limit. Center minus 3 sigma, this point is called lower control limit. What is our estimate? The what percentage of the curve will lie inside the control limit? 99.73.
1.73.
Right? And the control limits are nothing but the most deteriorated outputs. Can I say like that? Your best outputs are at the center. Your best outputs are outputs which are on the target. Your worst outputs are around the control limit. Am I correct?
Yes, sir.
If you make these worst outputs acceptable by your customer, it simply means everything you produce is getting accepted by the customer. Am I again correct? If you make the worst outputs accepted by the customer, it means everything you are producing is billable. For example, we produce white belts. Today we are going to produce white belt. The worst mark itself 75. The best mark is 95. Worst also saleable, best also saleable, right? That means no defect at all. This is the advantage, or estimate we are going to understand by referring to the control limit. If you know where is your control limit, you can judge on your entire output. This is this is based on the knowledge of normal distribution. So another characteristics of normal distribution is 99.73% of the outputs will fall inside the control limits calculated using process data. Clear?
Yes, sir.
You can apply this principle provided your data is clean and credible. If you don't know the importance of data, you collect the data the way you want. All these principles will still may not guide you. This is why we have been very serious about the measurement error. Measure very carefully, isn't it? Handle the instrument carefully, because if you mishandle the instrument and mishandle the measurement procedure, all these principles may not even help you, right? So we want to apply all these principles, and that's why our data should be clean and credible. All right, and now we do a little calculation. And see here, there are about few people here. Imagine I'm collecting the age of the people here, and these are assumed value, right? Not exactly your age, but let us know. But I can work with your age also. And see here, 6 people's age were collected from people who have attended my white belt session. I have picked up a random sample of 6 people, and the age is recorded. Why am I collecting this data? I want to understand what age group of people will attend my future webinars. You understand? What age group of people will attend my future webinars? I am going to judge. For that purpose, I collected some data. And now, with the data, I am calculating average. You know average, right? Average is 38.5. Average is 38.5. And now, I am going to calculate standard deviation. For calculating standard deviation, first I need deviation. What is deviation? X minus X bar. Now for the first number, can you tell me how much is the deviation for this data 39 from 38.5? How much is the deviation?
0.5.
0.5. Same way, I put deviation for every point. So total deviation when I calculate, it is coming to be 0. Does it mean there is no deviation? There is deviation.
There is deviation.
But deviation is happening on both sides. Normal distribution property, isn't it? Half value on the right side, half value on the left side. So deviation will cancel each other.
You
So
have to square it.
yeah, we have to square it. This is squared deviation. After the squared deviation, you sum up. Sum of the squared deviation is divided by n minus 1. Here n is 6. So n minus 1 will be 5. And that is 18.3. This 18.3 is called variance. You take the square root, 4.27. That 4.27 is called standard deviation. How is this information helpful to me? What age group of people will attend my Six Sigma program? Just by picking up a random sample, I can now make a conclusion. People in the age group between 24 and 53 will attend my program. Anybody here less than 24? You can raise your hand. Anybody here more than 53? There could be. Yeah. Outlier. Outliers are possible, right? Outliers are possible. And but when I work with more data, I can, my estimate can be more accurate. When I because this is just a random sample I picked up. But when I have more data, these rules will start working and then will guide you to take decision. Right? So how do I get the upper control limit? Formula is center plus 3 sigma. Average plus 3 sigma, 52.6. Average minus 3 sigma, 24.4. Which means there is 99.73% chance for people in the age group of 24 to 53 can come and attend programs like Six Sigma. Isn't it? After 53, generally people, don't show interest in learning, but he is an outlier. Vivek Kumar is an outlier, right? A special case. Similarly, people below age group of 23 or 24, they don't even know Six Sigma is required for them. This beautiful information, I could capture just by collecting data from the participant. Participant's age is a continuous data. Any continuous data from a normal process will follow a distribution called a normal distribution, and all the characteristics of the normal distribution you can apply. Hope it is clear to each one of you. And now tell me, answer this question. Average is a measure of central tendency or variation.
Central tendency.
And standard deviation is always a positive value.
True.
So very good, because we square and then take the square root. What proportion of points will lie inside your control limits?
99.73.
Beautiful. Write this number in some diary. This will be very, very helpful. Now, customer tolerance and the process tolerance. And there is a short clip for you to understand the importance of customer tolerance and process tolerance. Let me play this video and confirm me whether audio and everything is clear. Okay. Yes. So hope, what did you notice here? An elephant is taking a bath, isn't it? Now tell me, the bathing process, is it a challenging process for the elephant, or it is a pleasurable process? What is your opinion? Come on. Is that the elephant is enjoying or struggling?
Struggling to take a bath.
Struggling. And what is the reason for the struggle?
The tub is too small for him.
Size of the tub and size of the elephant. If both are almost equal, there will be a struggle. If the customer tolerance and your process tolerance are also equal, there you will struggle a lot in your business, right? So if you wanted to overcome, you must adjust one thing. Either the tub has to be adjusted or size of the elephant has to be adjusted. In the example I have shown, you can't adjust the size of the elephant, isn't it? Maybe you can change the tub. Similarly, coming to a business scenario, will you change the customer tolerance or process tolerance?
Process tolerance.
You can't change the customer tolerance, isn't it? The customer requirement is, no, customer is the king. You can't change. Process tolerance. So what is process tolerance? Upper control limit and lower control limit, right? Process center is average, and plus 3 sigma will give you upper control limit. Minus 3 sigma will give you lower control limit. You can adjust the control limit to make your business a pleasure, right? Let me change the tub size first and show you how, the situation changes from challenge to pleasure. I think now you are convinced and understood that you can change the situation in any business from challenge to pleasure. For that, you need to control the control limit, isn't it? Because customer tolerance, specification limit. Customer tolerance are called specification limit. Process tolerance are called control limit. Which one you can change? The control limit. Now tell me, how will you influence the control limit? What is the formula for upper control limit? Come on, guys. We have studied just now. What is the formula for upper control limit?
Mean plus 3 sigma.
Mean plus 3 sigma. So if you reduce sigma, what will happen to your control limit? Control limit will become smaller. It will start coming inward. So that's why it is very important to keep lower sigma. When I keep the sigma lower, control limit will come inside. If the control limit is inside the specification limit, you are running, healthier process, isn't it? Now, similar other example. Imagine you have a parking area. The size of the parking area, the width is capital D, and you have, a car like this. Car is bigger than the parking area's width. And tell me, will you be able to park this car inside? No. When the car size is bigger, and if you still try to take it inside a smaller area, your car will definitely get damaged. When your process sigma is higher to the extent that control limit can go beyond specification limit, rejections will for sure happen. On the other hand, if your car is smaller, car is almost half of the parking width. Your car is almost half of the parking width. Now your car is safe to parking any number of times. Consistently, you can park your car safer. Even 1,000 times you park, no scratches. But this situation, even one time when you park, there will be damage. Here, few parkings you can make, but not many, isn't it? But here, when the car is half of the parking area, similarly, when the process tolerance is half of the specification limits or the half of the customer tolerance, your process will operate with the double capacity, double capability. And such situation, we call it Six Sigma process. When you make your process operate with double the capability. See, here is, it's exactly capable. Car size and parking area exactly same. But in order to park this car, you have to be, extra careful. Otherwise, there will be problem. But here, even if small problem happens, still you will be able to park the car safer. This is how, Six Sigma is, reducing, your risk also, right? Hope all of you understand. So the customer endpoints are called the specification limit. Here the endpoints of the parking area are the USL and LSL. And car also has got certain edges, isn't it? This is what we call it, process limits or control limit, upper control limit and lower control limit. If the control limits are seen inside the specification limit, your process is capable. If control limits are seen outside the specification limit, your process is not capable. There are rejections. If control limit fall on the specification limit on both sides, your process is just capable. Just capable means a 3 sigma process. You know why do I call it 3 sigma process? I know control limit will be at a distance of 3 sigma distance from the center. Am I correct or not? So whenever control limit overlap with the specification limit, what is the sigma level of the process? Beautiful. If the sigma level is 3, what will be the success rate? Can somebody guess now? The success rate will be 99.7.
99.73.
Beautiful. How do we apply this number? Characteristics of the normal distribution. Normal distribution is telling me that 99.73% of your outputs will be inside the control limit. But my control limit is just touching the specification limit. So whatever rule I can apply to control limit, I can now apply to specification limit also. 99.73% of my outputs will be accepted by the customer. 0.27% of the outputs will now get rejected by the customer. When I produce 1,000 products, 99.73% of 1,000 is 997. 997 units out of 1,000 will now be accepted by the customer. But 3 units will get rejected by the customer, isn't it? So a 3 sigma process will assure you a success rate of 99.73. Then what will be the percentage of success rate for a 6 sigma process? Can somebody make a guess now? Will it be higher or lower?
Higher.
Higher, right? When you want more sigma, then you need lower standard deviation, isn't it? When you need higher sigma level, then your standard deviation should be lower. When your standard deviation is lower, control limit will move inside. When control limit move inside, your success rate will increase. For a 6 sigma process, which is doubly capable means the car is well inside the parking area. You still have some cushion on the right side, some cushion on the left side, isn't it? Even if you open the door, even if you stretch to the right, still your car will be safer, isn't it? So for a 6 sigma process, the success rate is much higher than 99.73. And the estimated value is 99.999666%. 99.99966%. And under such situation, the defects are estimated to be 3.4 DPMO. 3.4 DPMO. DPMO stands for defects per million opportunities. You produce 1 million products. How many defects will be there? Just 3.4. Right? How do we estimate? We have not produced 1 million product. We produced only a sample. Just for one day, I have run my factory. With what I observed in one day, I will estimate what is going to happen when I run the process for next 6 months. Do you understand how am I using statistics? If you use data to predict what is going to happen in the future, this form of statistics is called inferential statistics. What is this called? Inferential statistics. I am using the data to predict, what is going to happen in the future. Right? With my current process average, with my current process standard deviation, this percentage of output will be accepted by the customer. This percentage of output will be rejected by the customer. I can estimate, right? All that I required is average and standard deviation. Because with these two, I can get control limit. My customer has given me specification limit. I can do some little max and then, judge correctly on my process performance. Now there is a question to all of you. If control limits stay inside the specification limit, the process is considered capable or not capable?
Capable.
Very good. Specification limits are provided by manufacturer or customer?
Customer.
Very good.
Customer.
Customer will provide the specification limits, right? And the control limits are calculated using customer data or process data.
Process data.
Process data.
Process data.
What do you mean by process data?
Central tendency and the
Means
standard
what?
deviation.
Yes, process data means you will go to the place where the process is running, isn't it? And collect some sample output and measure the output for a particular characteristics. And then you will record your data in your data sheet. Am I right? This is called process data. See, so many decisions we take and the origin is process data. That's why you have to be very careful while collecting the data. When collecting the data itself is wrong, all your conclusions and predictions, estimations, everything will go wrong. And no company will trust you as a leader if you work like this, isn't it? So that's why you must master, how to measure, how to collect data, which sampling technique, which way I should collect the data, right? There are many, things very important to really become a leader. Your decision should also be correct. Your decisions will be correct if they are fact driven. How do you know it is a fact or not? Only through data. So that's why you should be very careful while collecting the data. So what is that we learned so far? Average helps us to find out whether our process target correctly or not. If my average is close to the customer target, that means my process is centered correctly. If my process is not centered, it simply means, the design of the process itself is wrong. Am I correct? If I conduct an examination and the average mark is, 70 and pass mark is 60. And now tell me, is this training program designed properly? Pass mark is 60 and the class average is, let me say, 80. Class average is 80 with some standard deviation, and which means all the students are comfortably above the pass mark, isn't it? So average is telling me whether my process is designed correctly or not. Suppose if the class average is 45, pass mark is 60, what does it mean? Everybody who wrote the exam is failed. That means the training program is designed badly. Teacher doesn't know which question will come and he talks something and something else comes in the exam. Similarly, if you know how to design a process, then your process center will lie on the target. If your process center doesn't lie on the target, it simply means people do not know how to set the process. Maybe machine setting, isn't it? Several things you do. All these things, if you do correctly, the process center, the process average will appear close to the targeted value. How many of you understand my point? Yes?
In this particular example,
Yeah.
let's say if the pass mark is 60, and we also target our process to be centered around 60, doesn't that mean that half the students are likely to
Correct.
fail?
So education industry is an exemption. We always want to be on the higher side. Our failures are only on the left side, not on the right side. So we will keep our target way above the pass mark. Let's say our target is 90. Now it is important to get average close to 90. Right? But manufacturing industry,
Right.
always
In these type of cases, we will have to see that the lower control limit is well above the pass marks.
Very good. Very well understood. Fantastic. If the lower control limit is above the target, then the entire class is performing fantastically. If you are a principal, if you are the headmaster in the school, you must keep an eye on the lower control limit. Very well understood. But if you are a manufacturer, you must keep your eye on the process center, upper control limit, as well as lower control limit. All right, fantastic. Standard deviation helps us to find out whether our process outputs are closer to the average or not. Lower standard deviation means close to center. But where is center? Center is on the target, right? And then a distribution is called normal if the data points are symmetrical about the mean. 50% on the right, 50% on the left. And 99.73% of the data points will stay within 3 sigma limits. These are called process extremities. The extreme output, the statistical name is control limit. A process is considered capable if control limits stay inside specification limit. Hope it is clear to all of you. Are we going good so far? All of you are finding it useful?
Yes, sir. Yes, sir.
Am I educating properly so that you can use this knowledge in your field?
Sure, sir. Definitely.
Fantastic. All right. So a quick run through of the define, measure, analyze, improve, and control, right? And define phase, we are trying to answer these critical questions. Is this project important to business? Business goal, project goal, are they is there an alignment? Isn't it? You want to learn, become a, Six Sigma expert, and I also wanted to teach Six Sigma. That's why we are together, isn't it? Otherwise, there cannot be an association. Similarly, your project goal should truly align with organization goal, and this is what this question means. Does a business case exist? If I do this, you will benefit. How? What will I benefit? If you do this project, the project results are impressive to you, or the results will also impress the business leaders. Business case, isn't it? For running a project, you require 20 lakhs. What will be the savings to the company? If the project cost is 20 lakhs and savings are more than 20 lakhs, then it's a good deal, isn't it? But if the savings are less, but project cost is more, then no company would like to support such project, right? A business case, a positive business case should exist. Have you identified CTQ? What is CTQ? Critical to quality characteristics. In an education industry, what is critical to quality? The test mark, isn't it? In a manufacturing product, the dimensional requirements are important. Surface finish requirements are important. The strength aspects are important, isn't it? In a service industry, how do you measure the service? For example, Swiggy. What is that Swiggy is doing? Swiggy is delivering a food. So what is that you expect from a Swiggy agent? You expect him to deliver the food on time, isn't it?
On time delivery.
Very good, on time delivery. The CTQ is delivery time as far as Swiggy is concerned. So every business has got certain characteristics which your customer will be interested in measuring. So before customer measures and finds a fault, you must measure and set it at the desired level, right? So identifying the CTQs is what is called defined phase. If you don't know what are CTQs in your business, it simply means you don't know what are your customer requirements, right? So without customer requirement, if you do something, and how pathetic the situation is. And our project plans and key milestones defined. Any project should have plans, goals, and milestones, isn't it? And then only the roles and responsibilities can be assigned. These questions should get answered, and these are all the tools required for you to do all these things, properly. What is this? Project charter, Kano model, SIPOC, Pareto chart, CTQ tree, Y equal to F of X, and toll gate review. If you say you have completed the defined phase, then there will be a review of your project in a company where Six Sigma is a culture, right? The toll gate review will be attended by project sponsors, project champion, and you should be able to defend on all these questions. Then only you will be allowed to proceed. Because why such a review is required? Because the company is investing you on your project. Because doing a project is not that easy. Resources are required, and effective people are required to participate in the project. And training is the biggest cost involved as far as Six Sigma is concerned. If you want to train that, if you want to roll Six Sigma projects, the first wave might require 20 to 30 green belts. In order to train 20 to 30 green belts, straight away an investment of 3 to 5 lakhs the company has to make, isn't it? So these are the barriers and challenges which company has to first overcome, and then only Six Sigma can be driven to success. Otherwise, it will be a flop. Many companies fail to produce result because they don't equip their people properly. If you don't equip your people properly, and what they will do? They'll do whatever they know. But what we expect them to work, perfectly. And if you aim for perfection, you must first equip them. So these are the tools, and which I will be, explaining to you when you join our main program, Green Belt Training Program or Black Belt Training Program. When is our next batch? This month, the 28th, we are starting next batch of Green Belts, right? So don't postpone your, learning journey. Postponing your learning, is actually postpones your growth. So don't do that. And you might have certain challenges, but we have designed the program very carefully that even a busy professional can comfortably learn with us, right? So all of you can plan for the 28th, And now this video will talk about how important it is to know your customer requirement. Should I play this video?
Yes, sir.
So what is the message here? What is the message here? If you ask your customers, they convey the requirements only in a vague format, isn't it? It doesn't mean that you can do whatever you want. You must go to the specific details of the requirements, isn't it? And that's where tools are required. You have to use tools to identify the CTQ. Not just, for one product, there could be 100 CTQ. Am I right? For example, you want to join a Greenbelt training program. What are your requirements? You just need certificate. You just want marks. There are many things, isn't it? And everything is a CTQ. And that CTQ means making the customer requirements measurable and actionable. So this is a Kano model, and Kano model will help you to categorize the customer requirement into 3 features. What is this? Must be. If your product failed to provide the must be, nobody will come to your product and nobody will come to your service. Am I correct? Certain features, if you mishandle it, you are completely out of the game. For example, a restaurant without a hand wash facility. Can you imagine a restaurant without a hand wash facility? Do you think such restaurants will be successful?
No, sir.
Right? So there are certain features which are must be. Whether your competitor is doing or not, you should do it. That is called must be. And once you understand all the must be, provide all the must be, and now comes performance. You know what is performance? Whatever features customers are expecting and whatever features your competitors are offering, it is very important to stay ahead of the competitors level, isn't it? For let's say I have I am planning to buy a car for a budget of 10 lakhs. Now I have 3 options. I can go for Hyundai, I can go for Maruti, and I can go for let us say Renault. So there are 3 brands under comparison. You know why I chose those 3 points? One is Hyundai, other one is Maruti, other one is Renault. Why these 3 brands I have chosen? Because all of them meet my basic requirement. Am I right? That's why I have made the choice. So the basic requirements, only when you handle it properly, your product will be in the preferred list. Otherwise, your product will not even qualify for the preferred list. Then comes another level of requirements. What is the mileage? Whether Hyundai is giving more mileage, or Maruti is giving more mileage, or Renault is giving more mileage. Tell me, how will you decide? The car which is giving a better mileage, you will go for it, or the car that is giving you a lower mileage, you will go for it? The better one. Am I right? That means now the choice is higher the better. Now the choice is more is better. So that's why it is very important to stay little ahead of the competition, and then only buying decision will happen. So must be feature helps in bringing your product to the preferred list, but performance features helps your customer to take the buying decision. Then comes the third one. What is the third one? Delight feature. You buy a car, right? And I will give you tank full of petrol. What is that? A delight feature, isn't it? So hand wash facility. Hand wash facility. Tell me hand wash facility. I told you it's a must-be feature, isn't it? All of you are listening to me,
Yes, sir.
right? So
Yes, sir.
hand wash facility is a must-be feature, I said. Now tell me, is that must-be features can be called as satisfier or dissatisfier?
Satisfier.
Satisfier.
I will call must-be features as dissatisfier. You know why? Even when I do well with respect to the must-be feature, no customer will talk about my product. Am I correct? Even when I do well, for example, will you talk about a restaurant? No, because it has got a wonderful hand wash facility. We will talk about the restaurant only if it offers a tasty food. Am I right? Offering a tasty food means no, it's a performance feature. But having a hand wash facility is a must-be feature. So must-be features never leads to satisfaction. But if you mishandle it, it will immediately lead to dissatisfaction. Am I correct?
Correct.
Now tell me, is that must-be is a satisfier or dissatisfier?
Dissatisfier.
So you have to be very, very careful with all the characteristics which are dissatisfiers. Very careful you have to be. No compromise at any cost. You must handle the dissatisfiers, properly. Am I correct or not?
Yes, sir.
So these are the deliverables from a defined phase. Approved project charter, and then we call a high level view of the process is required. We call it high level process map. And for that purpose, we use a tool called SIPOC. Supplier, input, process, output, and customer. So a simple 6-pack project charter will even teach you how to write this business case, problem statement, goal statement, project scope, project plan, or the milestones and team selection. Business impact should talk about the business results. Business results are mathematically the Z variable. Problem statement will talk about the pain metric, the CTQs, the Y variable. Goal statement, we set goal for Y. For that, we must optimize the X. Optimizing the X is the solution which we will offer it and improve. But before offering the solution, we never jump to solution, right? We define the problem, we measure the problem, and then we analyze, and then only we'll talk about solution. Generally, other trainings when you take, and they will tempt you to dive to the solution. But here we'll slow down and we'll make you go in the right pace so that when you actually offer a solution, that will be a perfect fit, right? And every project can be driven to a success. But there is a misconception that people think that Six Sigma means it's a failure. It simply means Six Sigma is not a failure. They don't know how to implement Six Sigma. They are not equipped properly. They just printed a certificate. They have not really equipped them to receive the title. If you print the certificate, and these challenges will happen. But if you really equip you on all the steps properly, every single project can be driven to success, right? So what are the deliverables from the defined phase? What does this stand for? PC means a project charter, but you should say approved project charter. A project is live only when it is approved. HLPM means
High level project.
high level process map. How many steps are there in defined phase? Very good. 3 steps, right? And what does S stand for in SIPOC? What does S stands for?
Supplier.
Very
Supplier.
good. Supplier. And who is a supplier?
The manufacturer.
Supplier, right? Anyone who is responsible for providing the input, right? Suppose if I expect all of you to complete an assignment, then I become the supplier. I have to give you the assignment, isn't it? Then only you can do it, right? So you have to always, go to finer details, right? Supplier is not always the one who supply you the raw material from Japan or China. Sometimes your supplier may be sitting next to you, isn't it? So measure phase. Have you identified the inputs and the outputs? Right? Because you have to collect data. Is your measurement system capable and adequate? Do you have an appropriate data collection plan? Sampling technique, right? And is the data collected appropriate for analysis? The data collected is considered appropriate if the error that is populated in your data is less than 10%. So it's very important to measure the measurement error, right? If you want to kill the killer, then you should be better than the killer. So in order to make your data speak better about the ground reality, you should also be able to control the measurement error. So first measure the measurement error and then see to that it is kept below 10%. And there are certain ways. We have the gauge R&R study, and then we have attribute agreement analysis, so that all forms of data you can estimate the error also. Because the beauty is the error also follows normal distribution. There are almost most of the process in the world will generate data that will follow normal distribution only. Just by becoming an expert in Six Sigma, you can almost solve all problems. Only very few cases will generate data that will follow other forms of distribution like gamma distribution, exponential distribution, and several other distribution. Even if the process generates data following other distribution, we are going to teach you one more concept called the central limit theorem. What is that? Central limit theorem. That will help you to restrict any process, generate only normal distribution. Do you understand what I'm talking? Which means almost 100% of the problem you will be able to effectively solve just by mastering one single distribution. What is that? Normal distribution. Even if the process generates a data which is non-normal, you can still convert the data to normal. That means any problem can be tackled and then future can be predicted using the principle of normal distribution. So the main output from the measure phase is the gap in performance. How far is your goal from the current performance?
Has he been put in front? An appeal, a big appeal from convinced ones. Into going for it by. No, he's gone for it. Still. Just from the top ribbing of the. This is the height factor. It's the height factor. Got to hit the stumps. You see that one stump when he is shuffling in. In line and hitting. Yep. Got a specialist, Mahendra Singh Dhoni. And finally.
See here, what happened is the umpire measured wrongly. Can I say the umpire has measured wrongly? The umpire estimated that the batsman is not out. Then the third umpire with a better sophisticated system, he could judge correctly that the batsman is out, isn't it? And the wrong decision made by the ground umpire is reversed. That has made the Chennai Super Kings to win the match. Similarly, if you don't correct the measurement error, which your team will be committing, the project that can be easily driven to success will be driven to failure. Am I correct or not? So that's why, it's important to measure the measurement error. And one more thing I wanted to show you. How the ground umpire, is able to take, a correct decision. He also used the data. Am I right? He also used the data. And look at the report, the output from the software. The path of the ball is tracked. At every moment, the path followed by the ball is tracked. Do you see a white color line? All of you see a white color line? This white color line is the real path of the ball. This is the point at which the ball has hit the batsman's pad. If the ball is allowed to travel further, it is estimated that the ball will follow the blue color line and then will hit the stumps. Now tell me, the blue color line, is it a straight line or will be a curved line? Come on, guys.
Straight line.
Blue color line, is it a straight line or a curved line? If I throw a ball, how it will travel? Will it travel a straight line or will travel a curved line?
Sort of depending upon the swing of the ball.
Depending upon the swing of the ball, right? So it is very important to
It can
understand
be straight,
whether,
but if there is swing, then the ball will have a curve.
so if the ball is moving in a straight line, it's called a linear curve. If the ball is going in a curved line, then it's called curvilinear. So once you have the instantaneous data that is collected from the data, you can easily judge whether the path is linear or curvilinear. If it is linear, just extend this. If it is curvilinear, extend the curve. Do you get my point? If this white color line is straight line, then just extend it as a straight line. If the white color line is a curved line, then extension should also be continuation of the curve, so that you can correctly judge on the whether the ball will hit the stumps or not. So judging the nature of the curve, the mathematical model of the curve, we are going to learn through regression analysis. What is that called? Regression analysis. Whether the relationship between x and y is linear or curvilinear. So we will understand through regression analysis. And of course, analysis comes in the third phase, analyze. And these are the tools you must master if to do well in the measure phase, right? Control chart, histogram, gauge R&R, operational definition, and check sheet. So these are the deliverables: validated measurement system and then baseline performance, right? So how to generate this kind of data, and then if the error is too much, and how to rectify that, and we are going to understand. So what is operational definition? The instruction, we give it to people to collect data. Am I right? So let me play this.
Okay, double click on my computer.
I can see your computer.
No. Click on my computer on your computer.
How can I click on your computer from my computer?
There is an icon labeled my computer on your computer. Double click it.
What the hell? What is your computer doing on my computer?
Double click on your computer.
Which icon do I have to click?
My computer.
Tell me, where do you live? I go to your house to click on your computer.
Oh my God.
So what is the problem here?
Communication issues,
Understanding.
because the communication is not correct.
Yeah.
Understanding
One-
problem also.
One such person will be there, in any project team. So he can easily, bring irrelevant inputs to you. So it's very important you make everybody collect the data, only in the prescribed way. For that, you always require operational definition, a clear and concise statement about the characteristics you want to measure. If you don't have the operational definition, and the similar confusion will happen in your project also, and your data can easily become an useless data, right? So these are the questions for analyze phase. So, and this is how we will train you on the various phases: define, measure, analyze, improve, and control. So I would like to take a pause here, and if there are any questions, please ask. Any questions based on what you learned so far? Yes. Any questions?
No, sir.
No, sir.
So does it mean all of you are understanding everything that I am teaching, or you're not able to grasp anything? What does it mean?
So you're teaching in a very simple way. So everything
So
is getting.
everybody is able to understand.
Yes, sir.
Okay, that's fabulous, right? But see, right. So few more things to learn, and as well as I'm going to inform you about some exciting, information about our upcoming training program, along with some special offers designed specifically for the webinar attendees, right? And those of you who are already in my class, you don't have to worry about all these offers, right? But those who are new, and you can really, look at the information, and then you can take some action so that you can, you will be proud of your decision, right? And see here, there are three types of normal distribution curves I am showing. This, which means, any business process can be represented in the form of a curve. If the curve is wider, it simply means the standard deviation of the curve is wider. Am I right? Is large. When the standard deviation is too much, as a statistician, your statement is this: it is difficult to produce output meeting customer requirement or within customer requirement. Under such situations, your sigma level will be very low, in the order of 0 to 2. We already learned that 3 sigma process means the success rate is 99.73. 2 sigma process means the success rate will be 95.45. 1 sigma process means a mere 68%. 32% of your output will get rejected. But how do I know the success rate? By knowing the process center and by knowing the process standard deviation. Whenever you see your process, appearing, wider, please understand your process is running a higher risk, and under such situation, the yield will be very low, the rejections will be very high. Rejections you can measure in the form of DPMO or defect percentage. On the other hand, if your process appear like this, very narrower, it means virtually everything that is going to come out of your process will meet the customer requirements. Under such situations, your sigma level will be very higher to the order of 6. The moment your process, sigma level becomes 6. When the control limit touch the specification limit, what is the sigma level? We said 3 sigma. When the control limit appears at the midpoint between process center and specification limit, you have doubled the capability, isn't it? And your process is 6 sigma. And now I am going to ask a simple question. When the control limit touches the specification limit, please tell me what will be the distance between process center and the specification limit? 3 sigma. That is why we call the process as 3 sigma process. Suppose if the distance between process center and the specification limit is equal to 6 times sigma, we are going to call the process as 6 sigma. That's why I said, your control limit should fall in the midpoint between process center and the specification limit, right? I think all of you have catched this point. A 6 sigma process.
Sir,
Yes.
please one more. Sir, please explain one more time, sir.
Yeah. If your control limit, see here, specification limit is here, am I right? And now what is this process? Tell me. What is this process? 6 sigma process or a 3 sigma process?
It
3
is
sigma.
3 sigma, sir.
How do I say 3 sigma? The specification limit and process center, how many sigmas are there? 3 sigmas.
3 sigma. 3
Under
sigma.
such situation, the success rate will be 99.73. Right? And
Yes, sir.
now I improve the process. When I improve the process sigma comes down. As the process sigma comes down, what happens? What happens? The control limit will be pushed inside. Have you seen the control limit moving inwards?
Yes, sir.
Now, how many sigmas are there between process center and nearest specification limit?
6 sigmas.
That's why now your process is called a 6 sigma process. And now the advantage is the result, the success rate of 99.73 will now become 99.999. Very close to 100%, right? And which means the rejections are limited to just 3.4 DPMO. This 3.4 DPMO is calculated considering the process as one-sided tolerance process. For a one-side tolerance process, the 3.4 DPMO is derived. Probably, I don't want to confuse you too much because in the initial stage, we will take it up a little later, right? And that's why, the learning, should be a journey. You see yourself a green belt and then a black belt, and then start practicing and get continuously mentored by a person who can really, mentor you, right? I've seen many consultants, they themselves don't even know the basics of statistics, and they cannot be Six Sigma consultant. Without statistics, you can't implement Six Sigma, right? Because Six Sigma is all about, data. So we have to be stronger in statistics also. And this we have seen. So ultimately, any problem can be solved, in my opinion. Any problem in the world can be solved using statistics. If the average is on the target with a lower standard deviation, everything is going fine. Consider your health metric, body parameters. Any body parameter, right? See to that particular body parameter, if you calculate an average, if that stays on the targeted value, you are at your best health. And also, in order to calculate the average, you might have used the data. And that data should have a lower standard deviation. This is a clear indication that you are going to live longer. Am I correct? Be it sugar level, be it your cholesterol level, if your readings, central value is close to the target. What is target? The midpoint of the extreme values. Doctor give the extreme values, isn't it? And if your body parameter lies in the center of the extreme value, that means your process is centered on target. That too, if it happens with a lower standard deviation, and you are creating a fantastic scenario, right? Any practical problem can be converted into a statistical problem. And by referring to just two statistical parameters, one is central value, another one is variation, nothing but the mean and standard deviation, you can understand the problem deeper, and then you can offer a practical solution, right? And this is called a systematic way of problem solving. If you don't use all these techniques and all these logics, then any method you use, in my opinion, that is just a trial and error method. Trial and error method, there is no guarantee that result will happen. But if you follow this method, and close to 100%, you are sure. And that's why we say 99.999, right? So close to 100%, you are perfect, right? So these are the benefits. The organization will get higher revenue. At the same time, their cost of poor quality will go down, and the organization will be able to utilize the resources efficiently. And importantly, the people in the organization will become super effective. If your company embrace Six Sigma, it means no more ineffective people can work in the company. Am I correct? Only effective people can continue the moment the company embrace Six Sigma, right? People who are really able to contribute to the organization's growth can survive the moment a company realize that Lean and Six Sigma is required. So that's why once the Lean Six Sigma is driven, a lot of training happens at all levels. You can see companies allocating budget for the training, because learning is very, very important, and this is what we call it the maturity level. Organization really comes to higher level of maturity only when their people become effective. And for individuals, these skills are directly, indirectly will prepare you for leadership positions, right? You will effectively solve problem, and then you will correctly take decision, which are very, very essential for a leader, isn't it? And you will learn to impact business result correctly, right? And then this will help you produce financial results for the company, and that means you will also be handsomely paid for what you are doing, right? And these skills can even take you close to the company you are dreaming for, either as an employee or as a consultant, right? And definitely possible, which means these learnings will help you succeed in your professional life as well as personal life. If you at least you must learn statistics to take care of your health, in my opinion, right? And any number you look at, you can immediately use statistics and interpret, and you don't have to wait for an expert to come and tell you what it is. You yourself can understand looking at certain data. So Sigma level is a measure of process capability. Specification limits are the tolerance limits provided by the customer, and control limits are the tolerance limits calculated using process data. A 3 Sigma process is just capable or mere capable process in which the short-term yield is 99.73, right? And a 6 Sigma process is a doubly capable process in which the long-term yield is 99.99966%, which corresponds to 3.4 DPMO for a one-sided process, right? In a 3 Sigma process, control limit will overlap with specification limit. In a 6 Sigma process, control limit will be placed, inside the specification limit. Of course, at the midpoint between center and the specification limit. Higher the sigma level, higher will be the capability. For higher sigma level, lower standard deviation is required, right? So sigma is different from sigma level. Sigma indicates your risk. Sigma level indicates your capability. We need higher capability and lower risk. So we need higher sigma level and lower standard deviation. Problem solving and decision making are leadership skills. And so it is absolutely essential for each one of you, for your success in the current profession as well as in your personal life, right? So this is the learning pedagogy which we strongly believe in, right? So generally people decide to learn certain new things, by coming out of the comfort zone. You can see, one best example, or Mr. Vivek, right? He can comfortably continue with what he has learned so far, but even at this stage, he decided that he must learn Six Sigma and other things. So he came out of the comfort zone, right? And maybe he got to know about himself, or his experience could have told him. And we can learn from him, and we can take advantage of learning, such things right at the early stage of our career, so that, we can succeed, very fast. So coming out of the comfort zone, learning new things will allow you to grow further, right? If you really wanted to grow fast, then you have to learn fast. And what is more important is, after you learn, you must put it into practice. Otherwise, simply learning without practice is useless. But practicing without learning is dangerous, right? You need to take care, right? So put it into practice and be bold enough to make some mistakes in the beginning. What is important is you must have the company of a right mentor with whom you can reflect your failures, with whom you can get it corrected, which means there will be a lot of learnings which will happen post completion of your training program, right? And always when you learn and look into all these aspects, right? And so when you learn certain things post completion of your training program during practice, and you will realize you are able to practice very well, committing fewer mistakes. There is no one who is perfect in this world, isn't it? So committing fewer mistakes is fine, which means you have become competent enough to practice what you have learned in the training program. And that will again put you back into the same comfort zone. So this is the pedagogy we strongly believe in, and we make sure all of you get back to the comfort zone, very soon. Once, if you trust us and come out of the comfort zone, we see to that we again enter into your comfort zone in the earliest possible time. Do you all now realize how amazing it is to become a Six Sigma professional? Have I done my job properly? Yes or no?
Yes, sir.
Very good, right?
Very much sure, sir.
Very good. If you also want to grab top level managerial roles and climb up the corporate ladder, right, and want to see yourself, on the top of the managerial roles, then joining this course would be a great option for you. And also, if you want to become a highly successful Six Sigma expert wanted by all companies, it's very true. Every company requires Six Sigma because every company requires profit. And you can decide to join my upcoming Six Sigma Green Belt training program. And one big offer for the people who are attending this webinar is, when you join, I will also offer you the Yellow Belt training program as part of your Green Belt training program. It's a double certification for you, provided if you join within today or tomorrow, right? And another thing. So this will be the learnings when you join our upcoming program, Green Belt training program. The first module will talk about the basics about quality, lean, and Six Sigma. Almost half of it you already know. And then the second module will talk about how to identify a project for Six Sigma, and then how to get our project charter approved. And then how to validate the measurement system, and then how to actually plan for the data collection so that we can actually measure the baseline performance, which is the module number 4. And there are several metrics, both manufacturing and service industries make use of. And for you to stay, fully comfortable with any business discussion or, any deal closing, and you will familiarize, with all these terminologies, and then we'll equip you on the analyze phase, particularly root cause identification, root cause validation. Validation is, proving the crime. Identifying the crime is first step, and then proving the crime is next step, and then checking the sufficiency, the number of
क्या हो गया?
how many criminals are involved in the crime, right? We investigate like the CBI, right, with the data. And then once having investigated thoroughly, then we enter into the solution phase, where we generate solution. For that also, we equip you with some appropriate tools. See a single program and then a control plan, so that you can sustain the benefits. A single program which can equip you with the multiple skills, right? Not just problem solving, not just decision making. And you also learn project management. You also learn how to communicate. You also learn, how to, affect the change. And there was a question right at the beginning of the program, how to, ensure the, people mindset change. So you will act like a change agent once you understand all these, tools and techniques. So 9 different modules of learning in one program, leading to dual certification. You get green belt also, you get black belt also, and this advantage is only for the webinar attendees, and that is allowed only when you take quick action, right? Today or tomorrow, when our team contacts you. And this is a special offer created exclusively for people of the webinar participants. And don't worry about your timing and other challenges, and we are there to support you. Even if you miss some of our classes, we can repeatedly permit you to sit in our future batches, right? And more over and above, every week, the recordings of the sessions will be provided to you right after the training program. And then live sessions will be there on the weekend. And you, with the recordings, if you can spend 30 to 40 minutes a day, you can comfortably, become a certified Six Sigma Green Belt. And most importantly, your standards will be way above, the ordinary green belts who are coming out from, the other sources. And you will see that we are bringing out some simple example, real life examples to understand even the tough concepts, and thereby, you can easily implement it, in your workplace. And of course, we will have a WhatsApp group, and the lessons you get lifetime access, and then you get a globally recognized certification. A rare combination of offerings comes to you, and over and above for those who could take a quick action today or tomorrow, right? Over and above all these things, you get some additional, bonuses. Like already I have promised a few things yesterday, and this is over and above, what we have announced already. So you will get, training videos on Minitab, my own training videos, so that you not only become an expert and understand the concept, you actually do the statistical analysis and how to do it with help of Minitab. On the other side, we are also going to provide you some, Excel based templates. So these templates will make you an expert in statistics, and the Minitab software also will make you an expert in statistics. That means all these laborious steps in any project have become, an easy thing for you. And these Excel calculators like, yield calculator, PP, PPK, PPM, and all those things which are worth 5,000 but free for you, right? And similarly, the project templates, project charter, CPOC template, project prioritization metrics, and fishbone diagram worth 6,000, and that also will be provided to you free. And some very good books on which will explain you the story of Toyota as well as the Motorola, and some good books like on statistical quality control and Lean and Six Sigma. And you will find all the reference material, including normal distribution table, a single source, right, can provide you, all the necessary details for you to execute the project. Whatever books we have been using, which are, which have costed us several thousand rupees each book, and I'm going to give away all those books free of cost, in a friendly manner. And over and above, once you become, a Six Sigma expert from Vision Excellence, you will be in our expert community where you can network with some of the finest experts, Six Sigma experts in the country. And we have produced people at all level. I could say, not less than 5,000 people, and I directly produce, right? And including people from white belt till master black belt, right? So a lot of opportunities our people exchange. So what are you waiting for? You can actually, join for the course, and the link for the course will be shared with you probably through the WhatsApp. And those of you who take quick action, you, and for sure, you will grab all the opportunities, right? And this is limited, and this is the fees. You will be paying, just 11,800 to grab all the offers which I have explained. Please note, this is only for quick action takers, right? And for as far as this workshop participants are concerned, whoever have, enrolled for the white belt, a certificate will follow tomorrow, and then the bonuses will also be shared with you. Notification will come, and trust me, I'll see to that, and all these things, are provided to you. So just for attending the workshop, in order to, just motivate you, and I will be sharing these templates, right? These calculator. This is for, attending the workshop. All right. So thank you for attending the workshop, and see all of you in the upcoming Six Sigma Masterclass, which will lead to, green belt and yellow belt certification.
So thank you so much for your nice program. I would like to ask you the question before the ending section. Maybe it would be the silly question. So can I?
Yeah, please.
Actually, the 5S terminology and Lean Six Sigma, are they, is there any relevancy between these two concepts?
Yes, 5S is a tool under Lean Toolkit. Lean has got several tools. 5S is one of the tools. The underlying principle of Lean is right sizing the resource and self-monitoring.
Okay.
What is that I said? Right sizing the resource. Another thing is self-monitoring. What is self-monitoring? One of the main principle of self-monitoring is visualization.
Okay.
So 5S is, neatly organizing your workplace. Am I right?
Yes. Yeah.
By neatly organizing, what are you trying to do? You are trying to bring the problems to the surface. Am I correct?
Yeah.
If there are no problems, absolutely fine. You keep the workplace neat and clean, and then, worker friendly, and thereby productivity improves. But if there are a lot of problems, the moment you implement 5S, you know what will happen? All the problems will start coming to surface.
Okay.
And thereby you fix the problem. So 5S is a good starting point for any company towards operational excellence. 5S is the starting point.
Oh, okay. Okay. Thank you, sir. Thank you.
Start, set in order. Then you shine, and then you standardize, and then you sustain. Right? So, so ultimately, it is just, an approach inside Lean. But by becoming a green belt, you are going to be way beyond, what people do using 5S.
Okay. Okay. Yes, sir.
Good question.
Thank you so much, sir. Thank you, sir.
So take quick actions. Don't think like this elephant, this big elephant thinks, like, things that, it cannot break the chain. So whatever challenges you face, and trust me, we are there to help you. Challenges in terms of time, in terms of money, in terms of, the mindset, please do take our consultation. We can help you, come out of all these challenges, because ultimately you should not miss this big opportunity by having these small excuses, right? So 28th May, an important date. Please mark the date and look here. The fees is already discounted. And similarly, the black belt also commencing on the date. And those of you who are eligible, you can plan for black. And otherwise, all of you can register for green belt. So that's it from me. Thank you. Bye-bye. See you soon in the classroom.
Thank you, sir.
Thank you, sir. Thank you, sir.